I'm a yay math.
I'm a leprechaun. I don't know what that is.
Just do math.
I'm a leprechaun.
No, mathemagoti.
Please don't stand the table.
Mathemagoti.
Mathemagoti. Okay.
That's extremely.
Mathemagoti.
Ready? 3, 2.
Wait, do I get to throw it or not? I don't want to.
You will. Yeah. 3, 2, 1. Hit start capture, and we're off.
Nope. It's on. It's good. It's good. No, it's not.
It's good. You're good. You're good.
That was always good. Okay, so we have Mathema Green Monster, Mathema Goatee,
Mathema flannel shirt.
Mathema Flannel. This is not even flannel. Mathema Goat, you know, Mathema
Potato.
Oh, I have a goatee, like. Oh yeah, that's cool. I got the joke. Is that how they? Is that the name of goatee? Seriously? A goatee is like. Why do I keep doing this?
because goats have goatees. They go down to here.
They go like this. Yeah, like okay.
Whoa.
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 Okay.
So
Whoa! 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 You're still doing it. Everyone's like, whoa, and you're like, what? You're still doing it. Okay. Let's start.
Yay math.
Yay math.
Yay math?
Yeah!
Take a shot, go. Go ahead. This, me.
It's embarrassing.
Come on, baseball players.
Okay, so this is the problem. So let's talk about it.
Okay.
Vertical asymptotes. We recall
How do we do those again?
from last time. Let's talk about it. Vertical asymptotes are the vertical lines in which the graph cannot touch.
Oh, I remember that.
So what is the value for x that is not allowed here?
0.
0. So do you agree that the line x equals 0 is where this graph cannot
Did you
touch?
just make this up?
No, this is example 1a on your paper.
Second page.
So let's make this VA. It's the state name for Virginia. So there is the line x equals 0. Any questions about the line x equals 0 is this vertical line, and that every x value on this red dotted line is 0. X is always 0 on this line. Okay. Now let's talk about horizontal asymptote. Flip, or not even flip, look at the top of your paper, and let's talk about the degree of the numerator and the degree of the denominator, right? And there's 3 different situations.
Aren't they 1?
So let's talk about it. You guys know what the degree of the denominator is, right? What's the degree of the denominator?
1.
1. Very good, because it's an exponent of 1.
Right.
So this is degree 1. What is the degree of the numerator?
1.
Oh.
1, because it's just
But
1.
wouldn't x to the 1 be degree 1?
Yeah, it's 0.
It is 0, right?
Really?
X to the 1, degree 1. X to the 2 is degree
2.
2.
Oh, I thought you just wrote degree I, and I didn't. Yeah.
Wait.
Oh yes,
It looks
degree
like an I.
degree 1.
Oh, I get it.
1.
Why? I don't
So
remember.
if x to the 1 is degree 1, stand over here. If x to the 1 is degree 1 and x to the 2 is degree 2, what would x
Nothing.
to the 0 be?
No degree.
Degree 0, right? We can say degree 0. And what is x to the 0 really?
1.
The number 1. So I'm going to put this here for just about a couple seconds and then I'm going to erase it.
Oh, I
Is
get
it-
it.
It's sort of like saying x to the 2 to the x times 2 to the 0.
Oh, wow.
And if it's x times 2 to the 0, 2 times x to the 0, excuse me, I'm saying it too fast.
So,
2 times x to the 0, this is degree 0. Because it's like saying 2 times 1. So I'm going to take it off. It's like saying 2 times 1. So in other words, constants are always degree what?
0.
Degree 0, yeah. And you hopefully have that right there on your paper. Question, please.
But if it's
But your hand was here, and then we'll take yours.
well, you know how when we have exponents like x squared over x1, it becomes an x?
Yeah.
So if it's x to the 0, then you subtract a 1 from the bottom.
Yeah, but all
But
we're
then
doing.
it's going to be, and then it's going to flip over into
Right, we're not simplifying though.
Right.
We're not simplifying. We're just regarding the degree of the numerator and degree of the denominator. Turtle in the back.
oh.
Question?
Yeah. But for 2, can't it just be degree 1?
No, because that would be 2x.
Why?
Because isn't the degree based on the exponent
Oh, yeah, because
of the
it's not-
variable?
Oh, you?
Okay.
Yeah.
So this is degree 0. If the degree of the numerator is less than the degree of the denominator, what is the horizontal asymptote according to your paper?
A line.
0.
What 0? Very good.
Y equals 0.
Y equals 0. So that's right on your paper. Horizontal asymptote, y equals 0.
I
Yeah.
don't understand.
Let's read that together. Could you read where it says number 1, degree?
Degree of a numerator is less than the degree of the denominator. Horizontal asymptote y equals 0.
Is the degree of the numerator 0?
Yes.
Is the degree of the denominator 1?
Yes. So
Is
it's-
that less than, is the numerator's degree less than the denominator's?
Yes, therefore
When-
it's equal to 0.
Therefore the horizontal asymptote is y equals 0. What does the line y equals 0 look like?
Flat. The
Yeah,
x-axis.
feeling it? Right, it is pretty much aligned with the x-axis. So these two asymptotes are where the graph will never touch. Okay, so now we can plot some points and see what happens.
Whoa.
So let's give it up. X and y.
So it's not gonna ever cross that line.
Yeah, the graph that we're about to graph, I'll graph it in blue, let's say, it will never touch an asymptote. Because asymptotes are the points which the graph, asymptotes are the points which the graph can't touch. So give me some points. Can x be
0.
1.
No.
Oh, wait, 1. 1.
1 is good. When x is 1, y is 2. Graphing it. 1, 2. How about when x is 4? When x is 4, y is
2.
1/2. Why not?
Felt
4,
like negative
1/2
1.
here. And let's do 1/2. When x is 1/2,
4.
4. Good job.
Ooh.
2 divided by 1/2 is 4.
Nice.
So 1/2, 4 would be here. So now, the idea of asymptotes is you can get close, you can hug them, but you no kissy. Why do I do an accent? Am I flashing back to something? No kissy. I'm like asymptote. So, indeed. Something like that, all right?
Why would it just keep going? What happens if you do negative 1?
We're going to do that now, yeah. So, for now, this is half of the graph. Yeah, we're gonna do this part. So notice,
Is that a curve?
as x gets smaller, yeah, it's curve.
Okay.
Yeah. As x gets smaller, y gets very large. And as x gets very large, y gets smaller. Over and over. Now I agree, let's do some negatives. How
Wait.
about x is...
Mr. Do
Okay, so what, we heard a weight? That's
Yeah, but macaroni.
Macaroni and cheese, okay?
Personally, I'm hungry. I just ate lunch too.
What's that?
I'm confused how we get the horizontal asymptote.
Okay, horizontal asymptote, name? What's your name?
Nikki.
Me?
Yeah.
Nikki.
Yeah, Nikki.
Nikki. Okay, Nikki just pointed out and read the first point here at the top of your page.
Yeah.
If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is always y equals 0.
Okay.
And that's the rule, all right? So just keep that rule in mind.
Yeah.
Yes?
So does the line get closer and closer to the x-axis? Does it ever like go out?
No. It'll
So it just-
get really, really close.
Gonna go 0.1,
Yeah.
0.01,
Yeah.
0.0,
Forever.
whoa, whoa,
Very,
whoa,
very
whoa,
good.
whoa,
Yes,
whoa,
yes,
whoa,
it comes
whoa.
really close, but never touches.
Forever.
Forever and ever.
How is that possible? Because there's an infinite amount of points.
There's an infinite number of points. 1 is all hiding inside this.
That is crazy.
Yes, please.
Is this only when it's the degree of 0? It looks like this.
No, it's just based on how it adheres to the asymptotes. So I want you guys to keep that phrase in your mind. This blue graph, which is halfway done, by the way, because we haven't done negatives, right? We haven't done negatives yet. If you want to start working negatives on your paper, feel free. But the way that these graphs work is that they come close to asymptotes. Notice it's coming close to this asymptote as well, but won't touch. And it's coming close to this asymptote as well, but won't touch. So our asymptotes could be anywhere. And we're going to see we're going to have asymptotes over here, over here. Yes?
Potato.
Yes, potato.
So for the negative, is it just opposite side? It's
Yeah.
the exact same thing, but on
Yeah,
the
you're going to see
opposite
it's going to be down here. Yeah. Yeah.
What
So
sector?
it's going to be in the third quadrant.
Or same thing?
It turns out to that. Yeah, but you will graph and see. So if x is -1, y is
Or -2.
-2. Let's graph it. -1, -2 is
Wait, the
here.
graph isn't over?
No, it's not. There's more points here, aren't there? And then
So-
we could even say, how about -2?
-1.
-1. See how it's going to do that as well? Maybe we can do an extreme value, maybe 10?
-8.
-8, sure.
Interesting.
-8 would be
-4.
negative
1/4.
1/4.
Why?
2 over -8. We're plugging in when x is -8, okay? I'm glad you asked, -1/4. And so that would be 3, 4, 5, 6, 7, 8 over here. So you see how it's coming really close? No kissy.
That
That's
was
a
the
very creepy voice. I suggest you don't do that voice. It's very, very creepy.
Hi. I just did the voice again, sorry. So any questions on this one? They're gonna get more challenging. All right, let's rock it.
Wait!
Sorry. Sweater. Who's laughing?
You should do like fast race, like speed it up.
I'll make this,
will.
I'll make this sound so you don't have to do it.
Hilarious. All right, flip the page. Okay, let's rock all these examples. Now, first step is vertical. Are there any vertical asymptotes?
Yes.
Yes, what are they? What is it?
4.
What for?
X equals 4.
Vertical asymptote.
I
Is
don't
this
get it.
x equals 4?
Oh, because it equals 0. Got it.
Right on. Because x cannot be equal to 4, so we can already graph that. Let's graph that on your paper.
Stop.
I'll graph the asymptote in red again. And we go 1, 2, 3, 4. X is 4 all across this red line. X is 4. Now, let's go to horizontal asymptote. You recall the rule about degree.
Yep.
What's the degree of the numerator class?
0.
0. What's the degree of the denominator?
1.
So the
One.
numerator will always be no.
No. So far it has. So if the degree of the numerator is less than the degree of the denominator,
Y
what's the
equals
horizontal asymptote?
0.
Y equals 0. So the ha is wa equals zara.
So how?
So it's Virginia and Ha.
Yeah, Virginia. Virginia and ha. Virginia's funny.
No, it's Vaha.
Vaha. And I'm going to graph y equals 0.
Smaha. You would know that word.
It's like on that cable TV shows.
And plotting points. When it comes to plotting points, let me make a suggestion. Notice vertical asymptote here at 4. So the action will be around this, won't it? Won't the graph either come up and hug it here, or maybe down from here? So I'd recommend plugging in points that are near 4. So instead of 4, what can we plug in for x?
8.
How about 3? That's a good joke. And instead of 3, how about
2. 5.
5?
Oh wait, yeah, sorry.
You're on fire, dude. Turtle. So yeah, I'm saying plug in the points that are near, so that we'll see what happens. So let's try 3. Watch what happens. If you plug 3 in for x, 2 over 3 minus 4.
Negative 2.
Right, because 3 minus 4 is -1, 2 over -1. So I'm graphing it. 3, -2. Graph it in a different color. So see, it's kind of doing what happened last time, except now the asymptote's over here.
Interesting.
What about 5?
2.
5, 2.
2. Oh, so when it crosses, there's gonna be a hole.
Yep.
There's no hole here.
Why not?
Hole is when the factors cancel. We're going to see those soon. So 5, 2, 1, 2, 3, 4, 5, 1, 2. Okay, now, based on what it looked like last time, predictions of how this will interact with the asymptote.
It won't touch
It
you.
won't touch you, right? But want to come close?
Yeah.
Wait, so
Know how it works?
it can't cross through it.
It won't cross through it, you're
So
right.
will it go up and over? Oh,
So
that's
notice
impossible.
horizontal asymptotes at y equals 0.
Yeah.
So why don't we start with the positive one over here? So let's start with my form. My form's
It looks really funny.
don't kiss. What happened?
Turn around and show us your back.
So I'll go over here.
Wow. Oh, and this.
Adhere to asymptote here, right here, and adhere to asymptote vertically.
So the 2 points, they don't have to have a connection.
No, they don't. They connect to their other friends over here. And so now we go this way.
Whoa.
Is that given that the line will go like that?
These types of graphs, yes. However, later on, or until then, if you feel comfortable
Don't you have to
graphing more
graph more?
points, yeah, you could. Like, give me one more.
7.
7? Well, 7's out here. How about something negative?
Right, but I just want to see if that it will. End
Sure,
up there.
7, and then it'll be small, won't it?
Let's see.
Y will be small. Let's find out.
Y will be like half or like an
It'll be
8.
2/3.
So let's go back to the original suggestion of 8.
2/3.
8. So 8 will be 2
One half.
over 8 minus 4 is 1/2.
We divided before.
Just kidding, I don't count.
So there it is, right? 8 1/2. Okay?
I believe.
Yes, please.
Will it always be on the vertical, not, the opposite or diagonal?
All times except one. I can answer your question. The bottom is squared.
And the bottom is squared and
Yeah.
the top one is
Whatever.
whatever?
Yeah.
So it'll be next to it?
It'll be next to it. Yeah, yeah. And do you understand why? If you square something, won't it always remain positive?
Yeah.
So friend will be upstairs.
Oh,
So,
Or-
but you'll see that later. There's an example coming up.
but if it's squared, the bottom it will never be on the bottom.
Right, right.
I never.
Yes.
This might be really bad that I don't know this, but how did you get the vertical asymptote to be?
Vertical asymptote, who can answer that? Because that's a good
The
practice.
degrees.
No,
Vertical.
good guess.
Oh,
Try here.
vertical.
T equals 0.
Yeah.
Your
My
denominator
bad.
can't be 0.
Denominator can't be 0. So in other words, x is not allowed to be 4, because that would be 4 on the bottom. Correct?
Wait,
What would 4 minus 4 be on the bottom?
0?
0. Is 0 allowed in the denominator class?
No.
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 So in other words, x is not allowed to be anywhere on this line.
Oh.
See how x is always 4 up and down this line? X is always 4 up and down this line. 4 0, 4 1, 4 2, 4 3.
So it's whatever x
Can't be.
can't be.
Very good. Yes. Yes, please.
How'd you get the horizontal asymptote?
Horizontal asymptote is based on degree. The degree of the numerator is less than the degree of the denominator based on your chart. Then the horizontal asymptote is always y equals 0. All right? It's
Is
number
the-
one of your 3
Is
cases.
the degree of a whole number always 0?
Correct. Degree of any constant whole number.
Of x is always 1 else. It says like x squared.
Wait,
Right.
let's say
X is x to the
let's
1,
say-
so that's degree 1.
Let's say the top was x squared.
So that's degree 2 over degree 1.
Which what happens
That's
there?
the third scenario. We're getting there. We're getting there. So, taking it off. Good questions, you guys. I've made examples for all of your questions. So I'm going to write the next one. Point discontinuity is the whole. We're about to talk about that. Okay, so here it comes. X squared plus 4x plus 3 all over x plus 1.
Oh, so this is what I said.
All right. Tempting to say that the vertical asymptote is where?
1 on the
No.
bottom.
Negative 1.
Yeah.
Right, I know what you
We
mean.
did this scenario.
It is.
It's tempting to say, but it's not an asymptote. It's just a point that's not allowed. Let's find out why. Why?
Because that factors to x plus 3 and x plus 4.
So we're going to factor the top and see that it can
Is it
cancel.
always able to factor that?
Many of the problems we do will be able to factor if it cancels, yeah.
But you said many, so not
Yeah.
all.
Many of the problems we do. Once we get there, yeah. Once we get there, we'll cross that bridge. I feel you. So I'm factoring the top into what, guys?
X plus 3, x plus 1.
X plus 3, x plus 1 over x plus 1.
You can't say that.
We do have a cancellation policy. So we're left with f of x equals x plus 3.
Over 1.
Right, over 1 we don't need, we just leave it. So what is f of x equals x plus 3? If I
Plug
wanna-
into our calc.
Well, it's like y equals x plus 3. Nice. What is y equals x plus 3? What is that? Is that a butterfly?
Line.
Is that a cupcake? Line. It's a line.
The butterfly.
Let's graph.
Butterflies and cupcakes are more interesting than lines.
I agree.
Okay.
Except that butterflies and cupcakes are created with lines.
Cut it a butterfly.
Butterflean. That's
Just
good.
build me a
So we're
butterfly.
gonna graph this line. All right, starting where?
At +3, 0, 3, y-intercept, right?
1, 2, 3. There it is. And then won't we apply the slope from
Yes.
here?
Up 1 to the right 1.
Up 1.
And down 1 to the left 1.
So we're gonna do that. However, now let's talk about this.
Wait, where's the asymptote?
Let's do, yeah, so we did vertical asymptote. We thought that the vertical asymptote would be at -1. Thought that was the case. But it's not because it canceled.
Right.
So that's done. Now let's do horizontal
Wait,
asymptote
why isn't there a real class inside?
because the denominator canceled.
So vertical asymptote, there is none.
There is none. Correct.
Only in
So-
this case.
In this case.
You wouldn't say that that the vertical asymptote is 0.
Correct. X can be 0. X can be 0. Right. So let's talk about horizontal. What's the degree of the top?
Square.
Wait, is there not a
One.
whole at -1?
Good job, we're getting there. We're getting there.
2.
Degree 2. What's the degree of the bottom?
1.
1.
So there's no.
And according to your breakdown, what is the situation when the degree of the top is more than the degree of the bottom? Go ahead.
None.
There is no
Yes.
horizontal
Wait.
asymptote.
So much easier.
Just best
When we're
example
looking
ever.
for the asymptotes, we don't look, we look at the original equation, yeah? Or
Yeah.
the new one?
We look at the original.
Okay.
Yeah.
So
Except
why
we
can't-
acknowledge that the vertical one canceled, so
Okay.
the vertical one canceled. But that's the right question to ask. Okay, so
What's
we,
the horizontal asymptote?
when the degree of the top is more than the degree of the
I'm
bottom,
just confused why
there
there
is
isn't
no
a
horizontal
vertical
asymptote.
one.
Reams, it's all good.
So there's no asymptote.
No, it's not. I'm confused.
Right. Oh, the reason why there's no vertical, originally, that's the proper question. Originally, you'd think that the vertical asymptote is where?
-1.
-1. And it would be if this didn't cancel. So if it canceled, it creates a what?
Whole.
A hole.
But I thought,
X is not allowed to be what point
I thought
still?
we look at the
-1.
equation. So that will be a hole. Is it still there?
Okay, you look at that for the degree, I suppose.
Oh, okay.
But even now, the degree is 1 to 0, so it's still more.
Okay.
So you look at
It's
what?
basically, it's like saying f of x is equal to 8/4.
Here, oh, X is not allowed to be -1. So where on this red line is X equal to -1?
Right there.
Here?
Yeah.
Right, at what point? -1, comma,
Well, you plug it into the
2.
equation, right?
yeah, you can plug it right
I
here.
don't understand why x is the opposite of -1.
X
it's not
can't be
equal.
-1. X can't be -1.
Why?
Because if I plug -1 here, what would happen?
0.
But doesn't it
The
cancel out?
denominator.
So isn't that the vertical
Even if it doesn't, even if it cancels.
So,
Even if it can, wait, we have two good questions.
so regardless of whether or
You have
not
to
it
look at
cancels,
this.
regardless of whether or not it cancels, if
Right.
the denominator, if you set x in the denominator so that the equation equals
So
to
you write an
0,
empty circle
that is where the
there?
hole is going to be.
Whoa, seriously?
That's
Yes.
awesome.
No matter what, even if this cancels, right, that's the right question.
Okay.
Even if this cancels, X still can't be -1. Okay.
And there can't be a horizontal because
The degree of the
numerator
is,
is over the degree of the denominator.
okay,
Do we need to have these rules
Yeah, you just
memorized?
have to memorize those.
yeah,
But I don't understand. If
Take
it
some
can't
notes.
equal -1, why is it not the asymptote?
because it canceled. Ow.
So
Because
there's
it canceled.
okay. So there's just going to be nothing that equals -1.
As long as, well, first of all, when it cancels, we're left with this. So this is what we graph. So, and we agreed that this is a line. I'm glad, that's great. So we agree that this is a line. However, within our line, we still have to acknowledge that based on the original, we honor the original equation and say that X couldn't be -1 here, even if we plugged it in. We plugged in -1 here and here, that's cool. Plugged in -1 here, and we're like, oh wait, X can't be -1 here. So the line basically skips over -1 and continues.
So there's a hole.
A hole. So it's also in your notes. It's also in your notes. That's awesome.
That was the strangest sound I have ever heard.
Can it be replicated? Do it again.
I can't do it again. I can't do it on the spot. Can't do it.
Mr. Dude?
What are you pointing to?
I'm like,
Oh,
Okay,
Sivan.
stop, everyone's
So
gone.
funny.
I still don't really understand.
Question on the floor. Yeah.
I still don't really understand holes. I don't know why.
If a factor cancels, it becomes a whole. Say it again.
I get it. If a factor,
Cancels.
top or bottom, or either.
On the bottom.
If a factor cancels, then it's a whole.
Yeah. It's called point discontinuity, and it's on the first page of your
Oh,
notes.
so that's the
My
whole.
brain doesn't work.
Okay, we're gonna go over it again.
And what happens if the denominator and the numerator are equal?
We're doing that next.
One more question, Mr.
Yes, please.
Why is it called the point of discontinuity if the line does in fact continue after the whole?
Because the line discontinues at that point, and
I answered my
So what do we write for that?
for point discontinuity, -1, 2.
-1, 2. Wait, what does that mean?
That's the point of where there's a hole.
Oh.
I'm glad. So next one, you guys see example D is, you guys are doing great. More and more examples are really gonna clear this up. So, any cancellations?
X? No.
No,
-2.
there's no cancellations right now.
No cancellations. So, are we talking about asymptotes down here or
Yeah.
holes?
No.
Asymptote.
Asymptotes. What is the vertical asymptote?
-2.
-2. What negative
So
2?
x equals
X
negative
equals
2.
-2.
Let's graph it.
Let's do it.
Let's do it.
Good.
Nikki, you're so funny.
Thanks.
Thanks.
Well, there's two Nickies all of a sudden.
Oh, Nikki.
Remember when Scrabble was called potato? Potato was Scrabble last week?
Yeah, I already remember.
Yeah, that was so awesome. Dude, let's talk about it.
Degree of the top and the degree of the bottom?
Degree of the top would be 1, degree of the bottom
Degree
would
1,
be
degree 1, right?
They're the same.
So the degrees are the same.
Oh, I'll tell you.
I have a question.
So then there's none.
No, there's a ratio.
It is. We're getting there. Question?
Let's say like it was x squared on the bottom and then it was 2. Do you add, or let's say it was x squared plus like x or something,
Uh-huh.
where there were 2 different degrees. Do you
Degree is
add
the
them?
highest exponent. No,
Oh.
highest exponent. Good question. So the degree of the top is 1, the degree of the bottom is 1. The second rule in your horizontal asymptotes states when the degrees are the same, the horizontal asymptote
1.
is y equals the ratio of the leading
Oh my
coefficients.
god, who made this?
What's the leading coefficient here?
1.
What's the leading coefficient here?
1.
1 divided by 1.
Wow.
1.
That's amazing.
So had this been 10x over x plus 2,
Fun.
it would be
10.
10. Good.
The
Had this been
horizontal.
10x over 5x plus 2,
It would be 2.
2.
Wait,
10
I
divided
have a
by 2.
question. So that's not the ratio.
It is 1 divided by 1. It's the
Wait,
ratio.
I have another question. You said that the. Will you say what you just said? I'm confused as to whether.
If the degrees are the same,
Right.
you divide the leading coefficients.
Okay,
And so that's y equals that ratio.
okay.
It's 1 over 1.
But if the degrees are different, of course, then you can find out the.
There's 3 different scenarios.
course.
So let's talk about it. Y equals 1. What does that look like?
It's y-intercept line.
What? Right. Okay.
Horizontal y line.
Okay. So these are the asymptotes to which the graph will adhere to. And let's go ahead and plug some points in now. So x and y. Now, recommendation is to graph points for x that are in the neighborhood of the x asymptote, right? So, what would that be? Take it easy, too.
-1.
Yeah.
-1 and then
-1, that's good.
-3.
And -3 is good.
And once we get those 2 points, do we need to do much more?
If you are comfortable with this stuff, you know that it's going to do this sort of thing, then no. No, at a certain point, you're okay. So let's try it. -1, let's take these off now. Let's do the bottom. -1 plus 2 is?
1.
1. -1 divided by 1 is?
-1.
-1. -1, negative, whoa. What happened? Oh no, that's good, that's fine. That's fine.
That was the last problem.
Okay. So, and now negative 3.
It would be
Negative 3 plus 2 on the bottom is
negative 1.
negative 1. Negative 3 divided by negative 1.
Negative 3.
No, it's 3 because the negative divided by a negative is a positive.
What, this one? The top one?
Oh, no, never mind.
Okay. No, it'll be negative over positive. So that's negative 3, 3 there, and
But they don't look the same on either side. Is that okay?
they should.
Huh? But
They both do this sort of,
Yeah, it's the same.
they sort of have a flirtation with the asymptote.
Wait, that's
Wait, what? Yeah, it's up. Remember before, in previous examples?
Negative 1, negative 1.
Will I cross through the asymptote or no?
No, you will not.
No, I
because
will
you
not.
can't. You're not allowed to.
So it goes here. And over here, feeling the same.
Nice.
Okay. Any discontinuity? Any holes here?
No.
No.
Okay, so really
Asymptotes.
fast. So, how do you find a hole though?
If a factor cancels.
So that's
What
the
do you
only
mean
scenario.
Remember last time we factored and the x plus 1 canceled? That's a hole.
That's only when.
There's a cancellation.
Okay, but then for the asymptote for this one would be negative 2 because it can't be equal to 0.
Correct.
But if the top was like x squared plus 4x plus
Plus
4,
4. Good job.
it would
X
be,
plus 2 would cancel.
and then the top would be x plus 2
Correct,
over 1.
which is a line.
Which is a line because
then
there is no, there would have to be a hole, right?
Right, the hole would be at x equals.
Negative 2.
Very good. So you grab, because x plus 2 cancel.
Okay.
Good.
And then it would just be a line.
It would
then.
just be a line with a hole.
Oh, okay. My brain is working today.
Okay, good. I'm glad you stuck with it. Okay, how many more do we have on the paper?
2.
2 more. Okay.
Let's do it.
We can do it. Ooh. Okay, this is an example that you just said, Turtle. Something like
That's
it.
the best thing of the day. Like that wins.
Yeah, it's fun. Alrighty. What's my first question going to be?
What is the vertical asymptote?
Yes. It can factor. X plus what?
3.
X.
Minus 3.
Lovely, lovely.
There.
My name is Watson.
Thank you for pointing that out right now. So don't these cancel?
Yeah.
So do we have a vertical asymptote?
No.
Do we have a hole? What's the hole?
That's 3.
3.
No, positive 3.
Negative 3.
Hot.
Because it's the bottom.
what do you write when it says vertical asymptote?
Excellent observation, Watson.
No vertical asymptote.
Oh, there's a point of discontinuity.
Correct. And that point will be, here, let's do our graph. So that's f of x.
So y equals x minus 3.
Yeah, I'm going to write f of x, but it's the same as y. X minus
What
3,
does the f mean? Function?
function of x.
So then when x is negative 3.
So shall we graph this line? How do we start it?
Minus 3
Negative 3 is the,
is the y.
very good, the y-intercept. Very slow y-intercept. And then sloppy joe. Yeah. And yeah. So the hole will be at what point of this line?
Oh, I know.
0.
No, it's gonna be
Do you agree it's negative 3 something?
negative 3, negative 6.
Negative 6.
Negative 3, 0.
Negative 3, negative 6.
Negative 3.
Negative 3.
Negative 3,
That's not on the line. Negative
Negative
3
3.
zeros here. So indeed, negative 3, negative 6 is where this graph has a hole.
Wait, why?
What's the horizontal asymptote?
Why is it called a hole, not an empty?
It's 2 over 1.
How did you get negative 3, negative 6?
Because when you plug in negative 3 back into the original equation,
Let me pose the question for you. Where on this line is x equal to negative 3?
Negative 6.
Negative 6. Good job. Good job.
Where did you, so you graph, you went negative 3 and then you
So negative. This is negative 1, 2, 3, and then that's 4, 5, 6 there, and then it goes right through. You guys are getting better at this.
I know.
Okay. So on your paper, when it says vertical asymptote, you write
None.
none. If it says horizontal asymptote, you write for this one, none. If you write point discontinuity, you have
the hole.
Negative 6.
one more.
And then, wait, when are we
And
done?
then 3 hours of math.
We could start. We have a lot of time.
No, we don't.
Wait,
What's up?
finito?
One more. One more.
One more?
Say that back to me.
One more.
One more.
Wait, I don't
One
understand what
more.
horizontal asymptote is.
Oh my gosh, there's a
What it
little
is?
black line on the board.
It's based on the degree. There's 3 situations for horizontal asymptote.
Yeah, but did we find it for the last one or
There's
no?
none.
Finally,
Oh, okay.
something.
Because if the degree of the top is more than the bottom, there is no horizontal asymptote.
Agreed.
It's on your 3 scenarios. Can you show her where that is?
No, I know where it is.
Okay, cool. Alrighty. What's my question?
What's the degree?
What's the vertical asymptote?
Vertical asymptote first, then we'll get to degree. What is the vertical asymptote?
It
One.
is,
What one?
What? X equals 1.
X equals 1. Va.
Wait, why don't we FOIL it?
Because factoring helps us see where that vertical asymptote will be.
Okay.
All right? Because if you FOIL, I won't know exactly what X can't be.
Why would that even be given to you if we just need one denominator? And they're both going to be x minus 1.
Oh, like because this is what Turtle was asking before about how since it's squared, it won't have top and bottom now. It'll be. I won't give it away.
Zip!
Okay, what's the va?
X equals 1.
Graphing. Can you guys do this one without me on your paper? Green.
Just like your short.
Okay, okay, but the top.
Okay, now
We need
degree.
a horizontal asymptote.
What's that?
Horizontal asymptote?
Yeah. What about the horizontal asymptote? What is it?
No, it's
What's this degree?
1 to 2 ratio.
0.
Degree 0.
So then it's greater, so it's 0. It's like.
Guys, stay with it. We have a few minutes left. You've been doing really well. Just let's finish this problem, and then we have time to work in class. Degree
0.
0. Degree. I assume that this is
2.
2. That's right. Because if you FOIL this out,
So y equals 0.
so y equals 0. Good. You remember the rule. So
Show.
ha. Wa equals za. And we graph the ha.
I'm not listening.
Wait. Because
I have ha's and va's all over me, don't I? Ha. My buttons are va.
I don't get it.
Ha.
Wait, because the degree is 0.
Where's the
Because the numerator's degree is 0, then
Yeah.
y is equal to 0.
Yes. No, because the degree of the numerator is less than the degree of the
Yeah, that's what I
denominator.
meant. That's what I meant.
Okay.
Well, it's
Now.
always going to be less if it's 0 because there's no degree to -1, is there?
No. Well, there is. It's 1 over x. But, you know, x to the -1 is 1 over x. So, graphing points.
Oh, this is weird.
Oh yeah. Give me a point for x in the neighborhood.
0, 0,
2 to 2.
0 and 2. Let's do that in red. When x is 0. 0 minus 1, good job, is -1 squared. So that's 4.
And look at this nifty little thing. It's gonna happen.
Right? And then you said 2. 2 minus 1 is 1, 1 squared is 1, 4 over 1 is 4. So that's 2, 4. Ooh, also here,
Yeah, I said it.
right? So,
Oh, you're not.
you want to try a -1?
What are you looking
You can do that. I'd like to.
My dad.
Hold on. Give it a chance. Give it a chance. Almost done. -1. When x is -1, what do we get?
Is there a reason you're graphing them?
When x is -1, it's 4
Oh, because there's no
over
room.
1. No, it's 4 over 4, which is 1.
1, okay.
Whoa.
How about 3?
When it's going to be 1. Interesting.
So, yeah, because of the square. The square does that.
That's crazy.
-1, 1 is here. 3, 1. See what's happening?
Oh, jeez.
And then here. And you recall earlier in today's lesson, we encountered a situation in which, how do you know when it's next to it or below and above? It has to do with this square. Okay? Right?
Oh.
The square makes it positive.
Both.
Yeah, both are positive.
One more question.
Last question, go ahead.
If both are positive, wouldn't it kind of be like this?
No, they're just about positive in terms of y. Y is positive.
And
Y is positive in this case. Because this is always positive, this is always positive, so y is always positive. Question here?
when you say both are positive, what are the
Oh, both of the sections of the graph. Okay, everyone, give yourselves a hand. Yay. Together. Did you already turn it off? Okay, I'll turn it off. Yay, Matt, yay. Did you turn it off?
No, yeah,
Yay.